So it's been 12:56. The night session started. So today we are discussing another topic. We continue our DP series in tomorrow's session. So let's start the new session with a new topic. This one is for the heap. Okay. So let's adjust my Windows screen. Okay. Okay. Let's start. So heap is a data structure. Okay. So let's see the heap intro video. So heat is a complete binary but satisfy the heap property. So max heap in which parent is greater than their children, and min heap where the children is greater than the parent. So in C++, the heap is implemented using, so in C++, so the heap is implemented using priority underscore QUE. Okay, priority queue. This is queue library. So in which we push the element, and mean heap is defined as, so mean heap. So how we make mean heap look like priority. For this we have to use the code section. So priority underscore QE. Okay, and priority queue. Okay, int vector of int. Okay, after that I use a greater something, uh, greater of int pq. Okay, so through this syntax we can write the we implement the min heap. Or for the max heap, simply we have to write priority underscore QUE int pq. Okay, so this one for the mean, this one for the max one. Okay, so no need for the custom comparator. So another type when we have to use custom comparator for this person, this section is for the mean heap when we want a custom one. So many times we have to sort two of the element. So in this at that time we have to use custom one. So for custom we simply create a struct. So how we do? So struct cmp comparator. Okay, and this portion, so bool uh, operator look like something. We have value of something like a vector of pair of vector in node a and node b, anything. For example, node a and node b or node b. So at that time we have to return a dot uh, a of frequency. Let's checking a of frequency is greater than b dot frequency. So we are just checking comparatively. So at that time we simply write this whole section, and only catch thing is, instead of greater portion we use cmp. Okay, comparator. So although this was basic of all the question, so mainly used in the finding the kth smallest element, like smallest and largest element, like chitra shortest path, top k element. So let's see the problem based on the priority queue or heap. So let's move forward. So priority queue. So let's see the heap section. So what is the pattern of questions heap question pattern of the heap question are as follows. Okay, So pattern one first type is introductory problem. Intro duct- introductory problems. So introductory problem consists of the implement the priority queue using binary heap sort. So does array represent heap? Is trees a heap? Operation on the binary mean heap, or convert the mean heap to max heap. So these are the introductory problem. So after that we move for the next one is after completing the introductory problem, we have to solve the implementary question. So implementary question. So implementary question. Okay, implementary question like relative bank, take gift from the richest pile, last stone weight, last number after digit swap by parity, minimum amount of time to fill cup. So minimum amount of time to fill cup, seat reservation managers, sort character by frequency, reduce the array size to the half, longest happy string, recognized string. So these are the question based on the implementary question of the heap. So task scheduler, single thread CPU, total cost to hire k workers, most frequent IDs. Okay, there is many more question on this implementary question. So after that after that we see the kth pattern question, kth pattern problem. Problem. So what is kth pattern problem? So in which whenever we see the k weakest row in a matrix, kth largest element in an array, kth largest element in a stream, find the sequence of length of k, kth smallest prime fraction, k closest point to origin, top k element, kth smallest element, find the kth chord, top kth frequent mode, find k closest element, ugly element, reward top k strength. All these k and kth pattern question solve using priority queue. Okay. After that, after that, after that, we see the minimize operation. Minimize operation. Okay. Operation, minimize operation. Whenever we have to minimize operation like these things, like remove the stone to minimize the total. So whenever the minimize operation take places, remove the stone to minimize the total, minimize operation to half the array sum, number of smallest occupied chair. The minimization things happen only using the priority queue. Okay, minimum sum to square difference, minimum cost to hire the k worker, minimize the deviation in the array, minimize the minimum interval to include each query. So these minimum things whenever you see in this question, simply think about the heap. Okay, after that after after that after that merge k sorted pattern. So merge k sorted pattern. Okay, whenever we see the this type of things, merge k sorted list, find k pair with smallest sum, merge k sorted array. So this one is generic question on the merge k sorted pattern. Okay, after that in the last we have to solve the problem based on two heap problems. So whenever you see the problem two heap problems, so in two heap problem, like number of orders, sliding window mediums, IPO, finding medium of the data stream, meeting room 3, time taken to cross the bridge. So these are the question based on a two heap using. So these are the only pattern on which the heap question came to our exam. So let's see which one. So introductory, okay. After that, implementary, okay. After that, kth pattern problem, okay. Mm, After that, we have to minimize operation things and the merge k sorted pattern. After that, two heap problem. So these are the pattern to solve the heap problem. So pattern to recognize the heap. So we solve one question from the two question from the implementary question and two question from the kth pattern. So for today's onward, for after day after tomorrow, we have to solve many more problem on this pattern. So let's see one problem based on let's take the use kth pattern, not kth pattern, implementary problem. So implementary problem, there is many more implementary problem. So uh, so most frequent id, so most frequent id, most frequent id lead code. Let's see how to solve this question. Most frequent id, so let's see. So you are given the problem involve tracking the frequency of the id in the collection that change over the time. You have two integer array nums and the frequency of equal length nums and frequency of equal length, and each element in the nums represent the id, and each element in the nums represent the id and the corresponding element. A problem involving tracking the frequency of the ids in the collection change over the time. You have two integer array nums and frequency of equal length, and each element in the nums represent the id and corresponding element frequency. How many time the uh, how many time the id should be added or removed from the collection at each step, okay. Addition of id, if frequency of I is positive, it's mean that frequency of id with the value of nums of I is added to the collection at step I, okay. Removal of id means frequency of id is negative, it's mean that negative of id or value of nums are removed from the collection at the step I. So return an array answer of length and where answer of I represent the count of most frequent id in the collection after ith step. If the collection is empty at this step, so answer of I should be 0 for these steps. Nums 2 comma 3 comma 2 frequency is equal to, so what, return an array answer of length and answer of I represent the count of most frequent id in the collection after ith step, okay. If the collection is empty at the step, we have to return 0. So 2 3 2 1, and this frequency is 3, 2 minus 3 and 1. Addition, if frequency of id, if frequency is body, it's mean that frequency id with the value id, the value of nums of I are added to the collection at that step. So after 0 we have 3 id with the value of 2, so answer of 0 is equal to 2 added 3 times. After that 2 id is added 3 times, okay. So and step 1 3, so we have 3 id with a value 2 and 2 id of value of 3. So 3 id of 2, as after step we have 3 id of value 2 and 2 id of value of 3. So answer of I is equal to 3. After that, as step 2, we have 2 id of value 2, and so the id become id answer of become, oh, so 0. After step 1, we have 3 id of value 2, so answer become 3. As step 1, or the answer of I, most frequent id in the collection after ith step. Most frequent, return the represent the count of most frequent collection after ith step. If the collection is empty, so this answer should be if collection is empty, answer should be the 0 for that step. Okay, the most frequent id is 3. After that, most frequent id is 3, and this step. And is this step answer of this at last step? In this step, we have to remove 3 ids, remove 3 id of 2. Okay, so in this step, after a second, after third, we have 2 ids of 3 and 1 id of 1, so answer will be most frequent will be 2. So we see in this question, so we have nums 5, 5, 3. So this means add 2 ids. So as a step, 0 step, we have 2 ids, 2 ids of the value 5, so answer will become 2. So after that step, we have to remove the 2 id. So first we include 2 id. After that step, we remove 2 id. So the id of 5 become 0. So at this step, we have to answer 0. And in last, we add 1 id of frequency, 1 id, one the frequency of id3 is become 1. So answer will be this one. So we have to answer the value. It's simply like this. So it is just like, it's simply like where value 5 5 and 5 and uh, 5 5 5 5 3 2 2 5 5 3 5 5 3 3 value, and its id. So what we have to do, first add it to id of 5, and then remove the 2 id of 5 and add the one value of id3. So what will the answer will be answer will be, firstly, most frequent id for most frequent count of the id 2. After that, there is no id left, so answer will be 3. Most frequent id is equal to 1. So the maximum value at that point we have to return. So use priority queue to solve this question. So how to solve? First of all, count. So how put the value? So we have to make a pair in which the value are inserted. If we see the frequency value is greater than 0, so we add increment the counter and push into the priority queue. If the counter is value negative, so we remove that value from our value. So initializing the max heap. So max heap. How to solve this question? Mm, so approach 1, consider two map, one another map. So max heap. So as we see, our answer is stored in the form of vector. So we have to write, so answer stored in the form of vector array. So int, so answer will be this one. So After that, after that, mm, we have to create a max heap in which the answer will be stored in the form of pair. So what let's see our approach. So right approach. So in this approach is simple. We just need push the item into hash map and the max heap. So create a hash map. The hash map always keep the hash map always keep the latest frequency of each ID, whereas the max heap may contain the stale entry of those might been updated later. Okay. So in this, first of all, create an steps to solve it. So in which answer vector. So answer vector in which our answer is stored, and the another map, create another map of integer and the count. So another map in which integer and integer value. So see the values. Okay. And the priority queue consisting of the pair of value of what, int comma q. So priority queue for the max heap. This one is a max heap. So we have tried max h. Okay. So we add the values inside the frequency table, or push the value, push the frequency of that element and a number that will. So run the loop while till the max heap become empty, and this become um, so intuition is just like creating an unordered map to store the cumulative frequency of each ID. So and for the each ID in nums, update the cumulative frequency in the map. Okay. Use priority queue to track the IDs with the highest cumulative frequency. As your ID, as your process each ID, push it into the priority queue along with the frequency. And while updating, ensure that the top element of the priority queue corresponding to the ID with the highest frequency. Return the vector containing the most frequent element. So the time complexity of iterating through the input vector is order of n. So each insertion and extraction operation take a log of k. So finally, the overall complexity is n log n. So what we have to do? Simply we creating unordered map. So this one is unordered map, unordered underscore map, mm, unordered map of int comma integer of mp. Okay, and create initialize the initialize the variables. Okay, and we have to store the answer now. So we have to create a vector of integer type of name as answer. The size will be size as the nums dot size similar as the size of nums. Okay, till now everything okay. So we create a max if priority underscore q in which integer type of data is inserted. So int comma int. Okay, pq. Okay, after that we run a for loop, run a for loop less than nums dot size. Okay, I plus plus. So if mp of nums of I, so we have to add the value inside the frequency table. So mp of frequency of what, frequency of. So we don't simply increment, we have to check oh if 5 is given in frequency table, how much value you have to increment? So in map, the 5 is the first value and the frequency will be like this. So 5 comma 3. So we see in this table. So okay, like this. So we are given this one is, and let's talk, this one is the value of nums, okay, and this one is frequency table. So when we create an order map, so we're simply seeing that MP of nums of I, if again 5, we have to increment this one, so become 0, okay. We're simply adding the frequency of all the element, okay. Hmm. We're simply incrementing the value of the map. So now at each moment we have to push the value and extract inside the our vector array. So vector answer. So pq dot push what? We have to push the value of mp of nums of I, the value 5, comma the value and 0 or 3 or 1 times and this one. So max if arrange itself, max if arrange inside and the maximum value will be at the top of the element. So run the while loop till pq dot size greater than 0 and mp of mp dot mp pq dot top element dot top second element is not is equal to pq dot top first element dot pq mp of pq of second element's value is not is equal to pq dot top first element, okay. If not is run this loop till so pq dot pop, okay. And in that case we have to fill the result, we have to fill value answer of I is equal to pq dot top first value, okay. And we have to in last we have to return the answer value, okay. This one is a simple one. Run and check is running or not. Compilation error, where we compilation error, pair of priority queue. Why we use two type of things. Priority queue of pair of int command. So simply we have to use pair of pair na. Simply we use this one, pair of int command. Compare return answer vector of long. So all this value are in long format. So another map in which we are inserting the value long value answer vector also become long. So I have to define pair of this value become long, and so all this sorted. I think almost everything is correct. So we have to see the only logic is that so mp of top dot second value is not is equal to pq dot top first value, okay, and greater than, and the mp dot 2 is not is equal to this one, okay. run this and pop this element. So this is one starter question for the priority queue. This is an implementary question. So let's move for the next question. Let's move for the next question. Let's see. Most frequent element is completed. Also see uh, frequent toward reward the case student. Reward the case student. Reward student lead code. Reward the case student. So this one is the question. Simply we solve this question without taking any too much time. So you are given two string, a positive feedback and the negative feedback, containing the word denoting the positive and negative feedback respectively. Note that no word is both positive and negative. Initially every student has a 0 point. Okay, each positive word in the feedback increase the point of a student by 3 and every negative decrease the point by 1. Okay, you are given an n feedback report represented by the zero index student array report, a zero index integer array student of I, where student of I represent the ID of the student who have received the feedback of report of I. The ID of each student is unique. So ID of each student is unique. Given an integer k, okay, return the top k. So here is the pattern of priority queue, top k, top kth pattern. Okay, so return the top k student after ranking them into non increasing order, non increasing, decreasing order. Okay, so in case more one student at same point, so if the student having the same point, so rank in from the lower id rank higher, lower rank id higher. So positive feedback, so positive feedback and negative feedback. Okay, the student is this one and k. So we have to return smart, brilliant, studious, negative. As negative one is not, report is this student is studious and the student is smart. 1 and 2. For feedback, smart, brilliant, studious, and negative feedback is not. This student is not studious. Okay, and the student is smart. So ID2 student get a 2 marks for his positive responses. So we understand the problem. We simply check the report value. If the word present in the positive side, a positive feedback value, we have written +3. If the word present in negative value, we have to decrement by value 1. So how we will do? So uh, run the loop for the both. Use hash map for storing the positive and negative value. So another set as many value. Let's simply write the code. In further session, we have to discuss in detail. So let's see. So we have to find the maximum point student at the top. So we have to maximum student at the top. So we have to use a maxif priority underscore priority underscore qe. Okay, of pair of int comma int. So term as pq. Okay, After that, we had to use another map for the another set, because many of the positive string can repeat it. So we put all this value in this set. So become remove the duplication, everything's okay. Unordered unordered set, set of strings, okay. Name as good. What is positive feedback? So positive feedback dot begin and good dot begin and the dot and end, okay. Simply we create same thing, control alt, same thing for the negative value. So negative value neg negative value, and the for take the negative feedback and put here negative feedback. All the unique value of from negative and positive value stored in the set, okay. All the positive and negative values stored in the set, and we run the for loop. So for loop, so it's starting from the int I 0 to I less than report dot size. So report dot size, where is report? So report dot size, okay. Report dot size I plus plus okay. And we also maintain the score. So a score table, so score will be initially stored will be zero value, okay. The data stream of the words. So convert all the value in the stream of words. So string stream ss report of I into this string, okay. After that, string word, okay, while ss while ss into the word. So I have to check if good dot count, if we count good dot count what the given word. So this means that the value is present, so score will be score plus is equal to 3. If we find the value in else if whenever bad dot count of that word, same word, if the bad dot count, if we see the bad dot count, so in this case we have to decrease the score by 1. So and also we have to push, and finally we have to push the pq dot push, okay. We have to push the score and the student id, so score with their student id, or score and student id, okay. And only these thing have to do. And after that we have to initialize a vector where we store the answer integer type, so in which the answer is stored, okay. So run the while loop. mm, Okay. So till end k minus 1, or we want end, we want k minus minus, so we want top k student. So in this case we have to push answer, but push back push back the pq dot top student id na, pq dot top dot second value. Okay, second value, and pop the element pq dot pop. Okay, and finally we have to return the answer. So return the answer. This is not complicated. We have to find the top k student having the highest score. So for the highest score, top student, so top k student having the highest score. So that's why we use maxi, and the positive response and negative response may be repeated. So we have to use another set in which we store all the positive responses from starting to begin, and also set a negative set in which we have store all the negative feedback is, and we run the loop on the report, and convert all the string value converted into word, and we check till the word till word become. So if we find the word inside the good set, so increment the score by 3. If we find the word into the bad set, so we decrement the size score by -1. And after that, all we have to push inside the priority queue score with their student ID, and we have to return the answer in the vector format. So we initialize the vector, and we run while loop till empty and till k minus 1. Okay, so answer put the top second and pop. So we see the value. So bad dot count, bad is not an inside, so simply we use a negative word now. So let's use bad word, bad. So this will be the why this value become giving the wrong answer. Let's see. So priority queue, we set the priority queue. Okay, we set the priority queue pair of this. Said this one is correct. This one is correct. For loop, okay, score will be 0, and we have to find in stream section. The stream section we pass the report of I word. Everything is correct. If we find the word in, so in descending order, so in negative. So the student after ranking in non-increasing order by their point, in case a student having same point, lower id first. So negative of this, what if it's negative of this? Hmm, let's see where we did mistake. Where we did mistake, let's see. Okay, Size of something, find negative inside priority queue. We don't have to simply use to make this answer correct. Negative of this value and negative. What this one? What it affect the value? So we are pushing if the score value is greater than if O. So actually using the negative value here is has a catch. If two-person having the same score, we have to place the lower ranking value first. Okay, okay, lower rank having lower rank ID having the first. So inside the processing on the queue, the process, if the process the person having the same score with a lower ID person get the chance or at the top of the element. So when we pushing this element inside, when we pushing that element in our answer, we have to remove the negative value and that we use just for the calculation in the PQ. Okay, so here we put negative value for the priority key operation and we remove negative value here for the answer sake of the answer. So submit. This one here only two things to remember. So what we had did, so simply write what are the steps we did here. So first of all we created maxip. So function, let's text code in function. So first of all we created the maxip. So maxip, how we created maxip? Simply writing priority underscore queue, queue in which we have to queue in which we have passed the pair of int comma integer. Okay, after that we have to store all the positive and negative responses in our set. So we created a set in which all the positive feedback starting begin and all positive feedback dot end value are stored. Okay, and in the set in which all the negative feedback dot begin and the negative feedback dot end are stored here. Okay, after that we run the for loop starting from i0 to uh, report report dot size value. Okay, or I plus plus. In this case we have to convert all the word written into the string format. So and also we want this code value, so we initialize this code to value and convert the string. So string, okay, as a ss in which all the values of report value is given in. Okay, so in which string word we have created also the string word, run this loop till ss become word. Okay, after that we have to check if the word is present or not. Okay, if that if good contain this word, so if good set contain this word. So this means that we have to score, we have to increment the score. So in this case, we have to increment the score by 3. Okay. Else if else if I found the bad count having this same word, like in which negative feedback having the same word. So in this case, we have to decrement the score value by -1. Score minus is equal to 1. Okay. And after all this, we have to push the value inside the pq. So during the here is the main catch. During the pushing the value inside the queue, we have to check, we have to firstly pass the score value. Okay. And if the score collided, the lower id person get the top position. So in this case, we add a negative at the student id. Okay. Just for calculation, not for n person. And after that, we have to initialize the answer vector integer. Okay. In which answer vector, and run the while loop for the pq till it become empty. Till it become empty, and also and a k minus minus. Okay. If any of these conditions fail, we came out from the loop. So in this case, we simply push the value, push back. And here is the catch. Here we add negative value on the student id, but there is no negative value. We are just using for the calculation, so we remove this negative value by adding extra negative value. So how we take really? Pq dot top element, second value is the id. So push the value and simply pq dot pop, and at last we have to return the answer value. So here is the pseudocode for the evacuation. Max if putting all value in set, converting a string stream. Okay. And here is on, everything is clear. So everything is cleared. So here it become an 1 hour session. So let's finish this session, and tomorrow we discuss some more question on different pattern of heap, and also continue the dynamic programming session. And let's tomorrow we have take a target to revise all the CS fundamental topics and start some system design question.